Hello, everyone. Welcome to the April 2nd edition of Math 262. Reminder that your website is due tomorrow, which is Friday. All right, so last time we talked about how you can use algebraic manipulations like adding, subtracting, substitution to find the power series of certain functions you might not have been able to figure out before. So today we're going to use differentiation and integration to help us obtain new power series. So this is, yesterday we began 9.9, this is 9.9 continued. Okay, so today we're going to use differentiation and integration to write functions as power series. All right, so we're going to begin with a classic example. And this example is the natural log of 1 plus x. So we don't know what the power series is for this function, but let's take a look at its derivative, which is 1 over 1 plus x, which is 1 over 1 minus a minus x. So this is a, this is r, this is the sum from n equals 0 to infinity of negative x to the n. Rewriting that slightly, this is equal to the sum from n equals 0 to infinity of negative 1 to the n, x to the n. This is the derivative of the natural log of 1 plus x. How do I find the power series of just the natural log of 1 plus x? What should I do? Well, no surprise, I should integrate both sides. So on the left-hand side, I will get the natural log of 1 plus x is some constant plus the integral of this sum. You only integrate the x part, and you get x to the n plus 1 over n plus 1. All right, so how do we find what c is? To find what c is equal to, you plug x equals 0 into this entire expression. So this piece right here is equal to x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Keeps going. So when I plug in 0 on the right-hand side, this whole part equals 0 when x is 0. And this piece right here, well, the natural log of 1 plus 0 is the natural log of 1, which is 0. So left-hand side 0, the right-hand side is c plus 0. So this tells us that 0 is c plus 0, which implies c is 0. Okay, so what this tells me is the natural log of 1 plus x is the sum from n equals 0 to infinity of negative 1 to the n times x to the n plus 1 over n plus 1. You can actually rewrite this series using a slightly different index. You can go from 1 to infinity of negative 1 to the n plus 1 times x to the n over n, if you prefer. These are equivalent series. Write them out and you'll see that that is true. So the question though is, when does this equality hold? When does this series converge? Well, let's ignore the endpoints. So we knew that this series converges on negative 1 to 1, which will tell us that our new series also converges on the interval from -1 to 1. Okay, so what we did there was we found a series and we integrated it to get the series of the natural log of 1 plus x. Let's do one via differentiation. So let's do an example using differentiation. So let's look at the function right here. X over 1 minus x squared squared. Okay. All right. So this is equal to the derivative of 1 over 1 minus x squared. Sorry, 2x right there. So you can check using your chain rule that this all works out. The question though is, what is this equal to? Well, this is my a term and this is my r. So this will be equal to the sum from n equals 0 to infinity of a times r to the n. So 1 times x squared to the n, or in other words, the sum from n equals 0 to infinity of x to the 2n. Okay, so that's what this is equal to. So what that tells me is the derivative of this function is the same as the derivative of this series. And what that derivative is equal to is the sum from n equals 1 to infinity of 2n times x to the 2n minus 1. You might ask, why does this series start with 1? It's because this series right here goes 1 plus x squared plus x to the 4th plus dot dot. And when I take the derivative, this term goes to 0 in the derivative. So what that tells me is using differentiation, I have been able to calculate that this function is equal to this series right here. And one can check that it's on the interval from -1 to 1, where this power series is equal to this function. All right, so I'm going to let you do 3 examples now, combining various things that we've learned throughout the last couple days. I want you to find power series for the following functions. Okay, example 1. The natural log of 1 plus x squared, where c is 0. So hint, use the series we just did earlier today and use a certain rule we learned last time. Another one is 1 over 1 plus 4x squared about c is 0. Hint, think about our infinite geometric series. Third, 2 over 1 plus x cubed about c equals 0. Now, this one, what you want to know is that you're actually need to do 2 derivatives. But the second derivative of 1 over 1 plus x equals 2 over 1 plus x cubed. So you'll need to use this fact right here to help you figure out what the power series will be. So give that an attempt in your notes right now. All right. So last but not least, we can evaluate certain series by recognizing that they're obtained by plugging in a particular value into a well-known power series. So we can evaluate some series by recognizing that they are obtained by plugging a value into a power series. Okay, so let's do an example, and I think you'll understand what I mean after I do this example. So let's look at the series sum from n equals 1 to infinity, -1 to the n plus 1 times 1 over 2 to the n times n. At first, you might be thinking, where on earth have I seen this expression before? And what you might observe is this is the same as this infinite series right here. Where we plugged in x equals 1/2. What series is that? I'm going to give you a minute to look at your notes. What series is this that I just wrote down? Well, you probably recognize that as the natural log of 1 plus x. And we know this converges when x is between -1 and 1. So what this tells us is that the natural log of 1 plus 1/2 is this sum right here. And we can plug this into my calculator and identify that that is roughly 0.4055. All right, now I'm going to give you an example to do. See if you can figure out what this series is equal to exactly. The sum from n equals 1 to infinity of -1 to the n plus 1 times 2 to the n over 3 to the n times n. If you have any questions about it, let me know. I'm happy to help. Otherwise, I will see you all next week.